Chapter. We're talking today about two-step equations. Yesterday we modeled two-step equations, and I asked the other question this time I want to ask you guys is, how many of you at the end of that day, you understood how to model two-step equations? Like you can go through the process. You could understand it for the most part. Okay? How many of you liked it? You're like, oh, this is not too bad. I kind of get this. I could do this for a while. Can somebody tell me why modeling might not be preferred for very long? Like, why would I not want to keep modeling, continuously? Sophie?
Because then you'd have to, you'd, do it, and it would take longer than if you could just, do it in your head, I guess.
Okay, yeah, I would say the time to take to model these different problems may take longer than doing it a different way. Yep, time-wise, you probably don't want to do it. Why is it not as great to model? Alex, what's the reason?
If you get bigger numbers, there's more models.
Yeah, and I'm going to say not only bigger numbers, right? I had to cut 20 small positives, 20 small negatives. You could do 40 of them, right? You could technically do that, but yeah, you get a lot.
If you wanted to see your work out, then you would kind of, unless you wanted to cut out.
Yeah, unless I recorded it, you're not going to see what you did. You just see your results. And what if I wanted to use fractions and decimals? What am I doing to those little boxes? I'm cutting those up and trying to get, it starts messing up after a while. So there's got to be a better way, right? And the better way is not doing it in your head, because I'm looking at your future, and I'm looking at your future like tomorrow and Friday and next week, and I'm also looking at your future down the road, down the years. There's got to be a better way. We can do it algebraically up here. Okay, this is a two-step equation. 3x plus 1 equals 13. And again, some of you can get that in your head, great. But if you can get it to me algebraically, that's way better. And that's actually showing more intelligence, because now you can show it through a difficult process. We're not going to work this problem out just yet. But it's funny up here, and sorry, Swivel doesn't see it. Solving, how many step equations? Two-step equations. Someone asked, Mr. A, you have 4 steps right there. I'm like, oh yeah, I guess that is 4. Okay, let me explain what this is. Don't write it down yet. The first step in any equation problem is to combine like terms. That's always what you do. So that shouldn't be new. It shouldn't be like, wait, combine like terms? No, you should always do that. And then the last step, which is check. What do you think about that one? Should you do that for 2-step equations? Yes. Should you do it for 1-step equations? 5-step equations? Yeah, always check. So really the 2 main steps are right here, 2 and 3. And I'm actually referring to something else with 2-step equations. How many operations are going on with 2-step equations? 2 operations. It's usually this way. You have either multiplication, division, and addition, subtraction. That's usually how it works. You have one of those and one of these. So what operations are going on here? Anyone know? Yeah, Matthew? Multiplication and addition. Good. So let's look at this problem now. My first step, and really in this problem, there are no like terms, so I put I because I want to identify. Well, what do I want to identify? What is happening to the variable first? Can anyone tell me what's happening to x first? You're like, first? How do you know it's first or not? Andrew, what's happening first? Yeah, it's being multiplied by... multiplied by 3. Yep, that's it. It's being multiplied by 3. What's happening to it second? Yes, sir? Added with 1. Okay, added with 1. How many of you think you can do that? You can look at a 2-step equation and say, first it's being multiplied by 3, and then it's being added with 1. Now, how do I know first and second? Think order of operations, guys. What would you have to do first here? You'd have to multiply, then you'd have to add. So that's how I got first and second. So that's my identify step. Whoa, that's not too bad. What's my third step up there? Really my second step on these problems? Undo. Undo. You're like, undo? What are you talking about? you don't have to rewrite these. These are, right, it's being multiplied by 3, and then it's being added with 1, right? That's the first and second. So to undo something, you have to reverse what was already being done. And some of you are like, what did you just say? Okay, here's a way you can think of it. You guys have played like youth group games where you have to like wrap someone up and then try to break them out as soon as you can. Have you done that with like tape or gift wrap or whatever? Okay, you do at Christmas time, yeah, because presents and all. So here's the scenario. You have to wrap Mr. A in gift wrap. Okay, you got to wrap me around here with gift wrap. And then you cover me up in a blanket, something you could breathe through, obviously. You cover me up with a blanket, and then you tie me up with a rope, like just a rope around my waist. Okay, what happened to me first? I was first wrapped. Then I was covered with, or blanketed. Yeah, I'm covered with the blanket. And then third, I am wrapped up with a rope. Okay, you guys get that? How are you going to undo what happened to Mr. A? You're first going to untie the rope, cut the rope, gnaw through the rope. You're going to get rid of that rope. What are you going to do after that? Take the blanket off. And then lastly, what are you going to do? Start ripping or pulling away at the wrapping paper. Okay, it's the same procedure here. What happened to this variable first? It was being multiplied by, and then it was being added with 1. How do I undo that? How do I unwrap that?
Subtract that 1, divide by 3.
Good. The first thing, I want to undo adding with 1. So what undoes adding with 1? Subtracting 1 from both sides. Oh, both sides. And I'm telling you right now, I know some of you hate the phrase both sides, but you're going to have to know that because I'm looking, I don't know how else to say this. Please do it. Please do it. Both sides, can you do that for me? But Mr. A, that means you got to write -1 twice. Wait, sorry. Time is up. Did I say subtract 1 or -1?
It's the same.
It's the same thing. If I say subtract 1, I can also say -1. You're like, whoa. I did this with the other class. What I'm trying to make here is I'm trying to make the point that subtracting 1 is the same thing as adding -1. And you're like, no, that's not true. Do you guys remember on that model? So another reference to the model. Do you guys remember the little clear dot? What is that? Or the clear box? What did that represent? How did I undo that? How did I get rid of it? I added one of these negative blocks, right? And then they undo each other, right? Okay, I added a negative. You know how else you could take away that white block? You could take it away. So taking away 1 or adding -1, guess what, is the same thing. Okay. If you're like, I don't get that, I hope you do soon because it's going to come up more. What's positive 1 minus 1? 0. What's 3x plus 0? 3x. What's 13 minus 1? 12. Awesome. Did I just undo the adding with 1? Yes, so how do I undo next the multiplying by 3? How do I undo it?
3 divided by 12.
You divide both sides by 3. I hate that, mister. I hate when you say both sides. It makes me mad. Okay, great. Good for you. Sorry about that. Feel bad. Here's a tissue. I don't know what to say. Those are my responses. But you got to do it because it's going to help you later on, especially as these get tougher.
So say I canceled out the 1, subtract 1 from both sides.
All right.
And I get 3x equals 12, but I don't divide by 3 and I just do it that part mentally. Have you found that wrong?
Yes. Thank you for asking because you're not the only one thinking. All you had to do is this, like put this little line, put that line. I know it's hard, but that's all you had to do. Okay, what's 3 divided by 3? 1. 1 times x? X. 12 divided by 3? 4. X equals 4. Now, I just undid what was happening. So what do I do next? Check. Now, Drew, for you and for anyone else, you can do the check mentally. That's okay. But here's my recommendation on the checking. If you check it and it doesn't work out, you probably need to start doing the check by writing it down. So if your checking is not working, like Mr. A, it doesn't. Every time I get it, it doesn't work. well, then you need to start writing things down because something's going up here that easily be resolved. What did I say x was? So does it really fit into the original equation? What's 3 times 4? 12 plus 1? Oh, whoa, that is the right answer. It does check. Okay, so you could check all of these. Every single one of them today, you could check and know if you got it right or wrong. Isn't that nice? Your quiz is on Friday. I need to put that up there. Quiz on Friday. It's up to lesson 3-5. Okay, 3-5. So not today's, not even modeling, yesterday. But can you check your work? Yeah, so you can actually put it on my podium and you know you got them right or wrong. Like you could know. But you're like, Mr. I don't like checking. Fine, let me check for you. I hope it's good. So you have the opportunity to figure it out on your own. That's your check step. Okay. Let's get this one right here. I'll write this equation down, please. And here's where I'm going to use all 4 of these steps. All 4 of these steps. Okay. Ooh. I got a 5D minus 3D minus 3 equals 4.2. Thank you for that, Mr. A. Okay. This is one of the problems you're going to get. Do you notice how I put C, I, and U? Does anyone know what that might stand for? Combine, identify, undo, and then my next screen, guess what it's going to be? Check. Good. Okay. First, I want to combine like terms. So looking at this equation, guys, are there any like terms on either side? 5D and 3D. Okay, these are like terms right here. And in fact, this is a review of terms from the first lesson. What are the 2 terms? Positive 5D and, oh, someone said it. It's negative 3D. Negative 3D. What's happening between those 2? All right, how many of you say subtraction? Between these 2, subtraction.
Well, now it is.
How many of you say addition? How can it be? It can't be. Wait, can it be both?
Yeah.
This is just for your benefit. Please don't write this down. If I wrote 5D minus 3D, isn't that also 5D plus negative 3D? Isn't that state change opposite? Am I allowed to do that, by the way? I am allowed. So what's going on here? Addition. What's going on here? Subtraction. But it's the same thing. And here's what I'm going to do. I'm going to poll you guys kind of. So some of you in your head, you're like, Mr. A, I hate what you say. I hate when you say adding and subtracting the same. I don't see it. I hate it. Some of you are saying, Mr. A, why are you saying it that way? That's kind of confusing. Some of you are saying, Mr. A, I kind of get that. I can see it go back and forth. And some of you are maybe saying, he's really annoying me by saying that so much. So I don't know who's who. I might have been spot on or dead wrong. But I think the sentiment is mixed. Some of you don't see that. That's okay. Some of you see it completely. That's okay. I'm building you guys all toward that eventually. And hopefully sooner than later. Okay. How do I combine 5D and negative 3D, or what do I get?
2D.
2D, yes. Regardless of how you see it, you should get 2D minus 3 equals 4.2. That's what you should get. That's your first step. You just combine like terms, you're done. All right, what's step 1? Step 2 is identify. So I'm identifying, and here's what you can actually start writing this down. Identify what is happening to the variable. Identify what's happening to the variable. So Brad, what's happening to the variable first? So look at the variable. What's happening to it first? Multiplying by, multiplied by 2. That's first. Drew, what's happening to it next?
It's being added. No, yeah, added. Well, subtracted, but you add to undo it.
So what's happening to it?
Subtract.
Good. And you're right. You undo that by adding. So I'm just asking what's happening, and then yes, you guys will get it down hopefully. Okay. Are you guys all in agreement? It's being multiplied first by 2, then it's being subtracted by 3. Guys, okay? All right. What's U stand for? Undo. And really, that's why I put these little quotation marks. If you really want to write down what it means, undo what is happening to the variable. Like undo, it's identify what's happening, then undo what's happening. So what do I have to do first? If I want to undo this, what do I do first? Drew? I'm just rewriting it for you guys. Go ahead.
Add 3 to negative 3.
Okay, and
divide to...
Oh, I heard it.
Both sides.
Very nice. Add 3. Thank you, friends. Add 3 to both sides. That's the first thing. Why? Because what do you have right now?
Subtracting 3. Well, you got to make it.
Keep it balanced. Keep it balanced. All right, good. What's negative 3 plus 3?
0.
Wait, is that negative 3 or minus 3?
Same.
Either way, it cancels out. What's 0 plus 2D? 2D. All right. What's 4.2 plus 3? 7.2. Great. Did I just undo the subtracting by 3? I did. How do I undo the multiplying by 2? Beth? Divide both sides by 2. Man, some of you are catching on. That's cool. You're keeping it balanced the whole time. And I'm telling you right now, Mr. A, I don't have to do that because these problems are easy. Okay. I will give you today a problem that you will struggle with because you refuse to do the steps, but we'll find out later. Okay. What's 2 over 2? 1. 1 times D?
D.
So I get D, I'm going to write up here, D equals, all right, what's 7.2 divided by 2? 3.6. 3.6. You're like, Mr. A, how did you get that? Well, you could just do 7.2 divided by 2. Remember, which number always goes in the box? The top number. The numerator always goes in the box. So divide it out, you get 3.6. All right, but is this my answer?
Yes.
Check it.
Okay, this is what you do. Again, you can do this mentally or you can write it down. You technically have to check this answer with the original equation because you could have messed up somewhere. But if you're really good at adding like terms, you can just do it right here. So listen, step number 1. Is that helpful?
Yes.
You know why it was helpful? Because it made this more convoluted or more complex into a simple equation. All right, what's 2 times 3.6? 7.2. What's 7.2 minus 3?
4.2.
Checks. That's your last step. And yeah, I didn't even have to write that on the next screen. That's your C step, your check, the second C. Sir?
Mister, will you ever give us different terms, like 5C minus 3D?
Not yet, because those are 2 variable expressions, and that's getting more algebra 2, but at the end of algebra 1. Do you want them now? Do you guys want those now? I don't mind. I mean, I can just pull out. Wow. William, be careful what you say. The class will revolt. Okay, let's get another one here. Here's your next equation. And go ahead and write it down, then we'll work it out together, and then I'll give you one to work on your own. First step is to combine any like terms. Are there any like terms up here? No. So we're done with step 1. Step 2, identify what is happening to the variable. So I find the variable. Hagen, what's happening to the variable first?
It's divided by 4.
Good. It's being divided by 4. Now, this step right here that I'm writing it all out, you don't have to do it, but if you're struggling to know what am I looking for and what am I trying to, this undo you're saying, I would write it out because you could just work backwards. Anna Grace, what's happening to it secondly?
It's being subtracted.
And for those of you who like abbreviating, you may do it here. This is your work. You can abbreviate. So it's being divided by 4, it's subtracted by 2. Good. Do you guys understand that? How do I undo what's already going on? Natalie, what's my first step to undo this? So up here is the first step, then I subtract it. So how do I unravel this? First, yeah. So not multiply by 4, but add. That's okay. Add 2 to both sides. Remember, Mr. A is wrapped up in paper and covered with a blanket. What do you do first? Take off the blanket and then unwrap the paper. So here. Blanket, paper. Paper, blanket. So get rid of the blanket first. What's negative 2 plus 2? 0. What is x over 4 plus 0? This is x over 4. What's 3 plus 2? 5. Nice. Okay, what do I do to undo the division by 4? Hudson?
You multiply 4 times x over 4, so 4 is 1.
Okay, good.
You multiply 4 times 4.
Good. So you multiply both sides by 4, basically, yeah. And you can say 4 over 1. Why did he say 4 over 1? Look what happens here. What's 1 times x? Oh, that's what I wanted. 5 times 4? 20. Nice. Is this my answer?
Check it.
What's 20 divided by 4? 5 minus 2? Oh, look at that. This must be the answer. Like, it's not, I hope it's the answer. It must be the answer. And you know it because you checked it. All right, how many of you are ready for your own problem? Okay, let's go here. All right, go ahead and work this one out. If I call on you for the answer, I don't want, I think it's, I hope it's, maybe it's either that answer you gave me or it's not. And you should tell me that way. So you should be very confident, or you should be, oh, that's not it. That can't be it. Yes, ma'am?
Check this one.
The last one?
Yes.
So you'd put 20 in for x.
Okay.
So you do 20, yeah, 20 divided by 4. There you go. Okay, I'm going to walk through this while you're working. Michelle, what's happening to x first? Good. Multiplied by, good, negative 4. Henry, what's happening to it next?
It's being added with 7.
Added with 7. Okay. Jackson, what do I do first then? What do I have to do? I just identified, but what do I have to do to undo that?
I have to subtract 7.
Finish that thought?
Subtract 7 and 3 by 7.
Okay. And you can say it like this, Jackson, so it's not, because that's kind of hard to say. Subtract 7 from both sides. That'll cover your bases from both sides. Both sides of what? The equal sign. That's what we refer to with both sides. All right. What's 7 minus 7? 0. Negative 4x plus 0? Negative 4x. Very nice. Negative 3 minus 3 or negative 3 plus negative 3 minus 7 or negative 3 plus negative 7. Huh?
Negative 10.
Yeah. Regardless of how I said it, it's negative 10. Okay. How many of you got negative 10 on that? Did anyone get something different? Like negative 4, negative 6, sorry, not negative 4, like 4 or 11 or 10. Okay, we're getting off on that, so be careful with your addition. How do I undo the multiplication by negative 4, Sam?
You have to divide by negative 4.
Divide what by negative 4?
Negative 4 and negative 7.
Which you could say is divide both sides by negative 4. This is a fraction bar. What's a fraction bar also known as? Division bar. What's negative? Oh, man, guys, I'm so sorry. What's a negative divided by negative?
Positive.
Oh, so what's negative 4 divided by negative 4? Positive 1. What's 1 times x? Oh, nice. That's what I wanted. And what's a negative divided by negative again? So what's 10 over 4? It's a couple ways you can do. You're going to get 5 halves, which equals 2 1/2. Or you could have said 2.5. Either one of these is acceptable. Why is a fraction or a decimal acceptable in this problem?
Because there was no fraction or decimal in the original.
Good. There's neither format in the original, so you can give me either format. Since neither, either. I don't even know if this works. Is this the answer? Is that it? Who checked it? Who checked it? All right, ready, guys? I'm asking those who checked it. What's negative 4 times 2.5? Negative 10. Right? Not positive 10. Okay. What's negative 10 plus 7? Does that work? Yes. Checks. It has to work.
We just did.
I don't mind waiting. All right, here you go. Last question here before I give you your final problem before the homework.
Why did you do negative 4 when you divided negative 4?
Yes, because what's negative 4 divided by negative 4? It's going to get me positive 1. And I want x to be positive x. So you could have done by positive 4, but then you would have ended up with negative x, which you have to do another step after that. You're welcome.
Oh, this is really hard.
Thank you.
All right, mental mathers, put your pencils down.
Why?
Because you can do this, right?
There's 2 variables.
Yes, there are 2 variables, but they are the same. So that's nice, thankfully. Yeah, I'm not going to give you like an x and a y. Can't do that yet. Not yet.
We're going to learn that.
Sooner than you think. I was going to say sooner than you would like, but I don't know about that. But sooner than you think. First step. Are there any like terms?
Yes, there.
Actually, you know what I did to the other class? I actually gave it to them in this format. Isn't that scary?
That helps.
Yeah, it did. It makes it a little less. Little less. I don't know what's going on. I just added the 1 because there is a 1 there, isn't there? So now same thing. But seeing that 1 helps some of you. Oh, okay. Okay. Whoa.
Is that a fraction?
This is a term, this is a term, this is a term. And then you have the 5 out there, but that's on the other side. Are there any like terms?
Yes.
Okay. How many of you agree that these 2 are like?
Yep.
Okay. I need to combine them. So really, to combine these 2 terms, I have to add their coefficients. What's the coefficient of this?
1.
Negative 1. All right. What's the coefficient of that? Sorry, someone said negative, but it's actually positive, right? So you're doing what's negative 1 plus 4/5? It is not negative 1 and 4/5.
It's 1/5.
You guys are getting closer. Okay. Negative 1/5. Because you got to get common denominators, right? You get negative 5 over 5 plus 4 over 5. You guys see what I did there? Common denominator? I just multiply this by 5 over 5. Do I have a common denominator? What's negative 5 plus 4? Negative 1 over 5. Uh-oh. So it would be negative 1/5 x minus 2 equals 5. I mean, you could just say you get it. You can leave it like that. I think it might help out. So now it's a 2-step equation. I'm done with step 1. What's happening to the variable first?
Multiplication.
Multiply by negative 1/5. What's happening to it second? Subtract with 2. What do you undo first?
Subtraction.
What undoes subtraction of 2? Oh, okay. You mean like we did before? Yep. Even with fractions? Mm-hmm. All right, I get this. But, oh man, what do you think you have to do? What undoes multiplication of negative 1/5?
Times negative 5.
Oh my goodness. What did you just say there, Anna Grace?
Times negative 5.
I thought you divide by negative 1/5. How many of you say divide by negative 1/5, right? But what property is Anna Grace trying to apply by multiplying both sides by negative 5? Properties, they strike back again. Yes.
Inverse property of negative.
Very nice. If you multiply both sides by negative 5, you're like, why would you do that? Well, isn't it really negative 5 over 1? What happens to these guys? They cancel out. What's a negative times a negative? Positive. What's positive 1 times x? It's x. I got rid of that without having to divide both sides. And then what's 7 times negative 5?
Negative 35.
Negative 35. That's the answer. Ooh.
Check it.
Oh, thank you for the request, Hudson. All right. I need you guys to help me out because Mr. A's mental math struggles a bit at times. All right. I say x equals negative 35, right? That's what we said it was. Okay, let's check the original problem. What's negative 1 times negative 35? Positive 35. Very nice. All right. And then the negative 2 is still there. What's 4/5 times negative 35? 4/5 times negative 35 over 1. Yeah, we're going to get negative 28 equals 5. But I don't know if that's even true. What's 35 minus 2? 33. 35 minus 2 is 33. Minus 28?
No, 5.
That works. It has to work. Is this a difficult problem? You have one of these on your homework. One. Oh, yeah. Not Friday's quiz. This lesson is not on that test. Two to 12 even. Happy Halloween.